Thank you for having me, B-Sides. My name is Arshan Dabirsiaghi. I was born in GBMC, right there down the street. Lived in this area my whole life, within 10 minutes of here, so it's awesome to be able to speak here. So thank you for having me. I've been in AppSec, so where coding meets security, my entire career. Once I became an adult and I had an official career in information security. So I've been focused on, in the beginning it was on memory corruption kind of stuff, and then I kind of moved up the stack towards AppSec, and I witnessed a lot of changes over that time, but I think there's some more drastic changes that are coming that I think we need to be thinking about. I've made tools, I've been consulting, code reviews, pen testing, and threat models, and anything you can imagine, sort of in and around that space. That's my background. So everybody's probably familiar with GitHub Copilot. Have you seen GitHub Copilot? It's a really cool tool. If you haven't seen it, you write some code, and GitHub Copilot predicts what's the next line you want to write, and sometimes it predicts the next 4 or 5 lines. And I started using it whenever it became available to me, and I really like it. It's right. For me, it feels like it's right. I don't know, 50% of the time, and it feels like a average, a little boost to my throughput, to my speed. It doesn't feel super transformative, but they've done some studies now. McKinsey and Microsoft have done studies. Trust McKinsey a little bit more than Microsoft on this. But so McKinsey says it is leading to a 25% improvement in throughput. And so that's relatively serious. In a lot of jobs, if you could all of a sudden do 25% more, you have my attention. And it was like the most widely adopted sort of AI tool, and then ChatGPT came along and destroyed that. But it's still got relatively strong adoption. And most enterprises that I talk to are going through the evaluation now of bringing in tools like this. And if you've had a chance, now the IDEs like VS Code and IntelliJ have another sort of interface to talking to the LLMs, which is what they're calling assistants. And so you chat with something inside the IDE, and then it drafts not just like an autocomplete, but like a whole file, a whole function, a whole something more. We have not done any studies on. There's no results released on any studies about what the throughput gain from these types of tools are. We don't know what the adoption is yet, but still. And has anybody used the assistants in the IDE? Yeah, it's not as popular yet, but you can give it a try in lots of IDEs, and it's interesting. It's not. I wouldn't say it's great yet, but you can see where it's going. And I have no doubt that they will get there. And then if you think about, what's next, a couple weeks ago there was a tool release called Devin to great acclaim on your social networks there. And the idea is Devin sees a ticket posted to your GitHub, and it really tries to take on the whole task of what a developer would do. It makes a plan. It sort of officially lists what it thinks the requirements are, and it tries to execute to those requirements. And if you looked very closely at the end of the GitHub Universe keynote last year, at the very end, their Steve Jobs one more thing kind of thing was something like Devin, where you would give it an issue, assign it to Copilot, and Copilot would try to make whatever changes to the repository to make you happy. And so if we think about what is the throughput going to be, additional code throughput from the autocomplete to that thing I just described, it seems every business analyst's fever dream can become reality by asking Copilot to go do it for them. The throughput of code, I think, is going to be shortly pretty crazy. Anybody think that's bullshit? You think it's what part of it? Oh, you think Devin is bullshit? Yeah, there's a little bit of smoke there. I trust GitHub to execute a little bit better. But there's some tools like this, like there's some that are open source actually that do a little bit of this, like Aider, AIDER, and there's a couple that are definitely going the right direction. But it's gonna be a wild world here pretty shortly. Another very important thing to throw into this mix is that LLMs they write insecure code and then they lie to you about it. So they've done a bunch of studies now. There was even one yesterday that just reached the preprint server about how well does these things like understand vulnerability classes. Every vulnerability class is different, and I'll tell you, it does a great job at SQL injection. Probably because SQL injection is like the most widely discussed vulnerability class out there, and so the literature is just overwhelming, and so it does know it really well. But if you ask it even like one vulnerability that's like even slightly less popular, it does not really know what it is. It doesn't know how to reason about it, and the fixes it suggests are wrong. And so, they did a study where they gave it some programming exercises, and a lot of times it came out with the wrong answer. It came out with an insecure piece of code. And ironically, the developers, you ask them afterwards, and they were more sure of the security of the computer-generated solution rather than the human-written solution. And then, of course, if it asked the LLM, "Is this secure?" the LLM said yes. And it comes up with some like 3 paragraphs of like inane babble about why it's secure. And the developer can't really sort out the difference, right? Because they're not super cross-trained on all these security issues. So we're about to create a lot more code. This isn't like 5 years away, like maybe, like it is happening. And the code is less secure with more confidence from the developers. And so yeah, that's not good. And you might wonder why it's vulnerable if you haven't been in this thinking about this too much. The GitHub and really anybody who trains models, they take human code, which has bugs in it, and it learns how to write code based on that. And so the LLM suggestions have those same bugs. It's trained on insecure code. And if I know that y'all have had this experience where you go to Stack Overflow and you look at something and it's like, the insecure answer is the top one, and then you go like to the next one, and like somebody's like, "Hey, actually, it's this thing. This is better," but developers don't know because they don't know what is the security question they should be asking themselves about that thing in order to know that they need this other security control sort of involved. And so the LLMs actually are. They want to make developers happy and they don't really care about security. So if an LLM gives you a secure answer and their competition gives you an insecure answer, but it's what you expect, that's what the developer's going to vote with their feet to use, because it gives me what I want and what I expect. And so there's this perverse incentive where they're sort of incentivized to produce insecure code on an individual level. So the question that I asked myself was, can't the models just like generate secure code? And like I mentioned before, like they don't really understand the vulnerability classes. They can't reason about them. SQL injection, again, being like sort of the one example that they are really good at. But if you really, the rest of it, you really can't. And by the way, a vulnerability is this emergent phenomena across lots of different places. Some of it is in your code, some of it's in your libraries or frameworks, and some of it's in the runtime itself. And so understanding all of this and reasoning about all of these different places is just science fiction right now for a model to do that. They can't remotely do that. Even if you give, even if you look at the most recent research about, they have a 1 million token context window, meaning you can fit a lot of code into a question you ask to an LLM. They can do search through that space, but they can't effectively reason about such a deeply complicated vulnerability path through that code. So, yep. And so it's worth pointing out that I even made tools in the market that try to like purpose built to do this, and it's extremely tough. Even if like what you're looking for is super well understood, it's very difficult to do this. So to ask an LLM to use incomplete information in the very weird black box way in which it works, it's quite difficult, and it's very slow. You generate answers at the speed of inference, but if our static analysis tools that we all use today are extremely fast. They've been optimized for 20 years, and they've had thousands of man years put into them, but it still takes hours to scan reasonable sized code bases. So to think that so we've sort of boiled the problem down, we think as efficiently as possible to solve statically, and so the idea that we just throw it at an LLM just sort of doesn't pass the sniff test. I talked about this a little bit already. Like developers, I don't think they'll reward the secure model output. And this is an example here. So the text is super small. Sorry about that, but the developer, when they write XML parsing code in Python, they would just want to say xml.parse. And the secure way to do that is to prevent a vulnerability class called external XML entities would be to use this thing called diffused XML. And so when a developer looks at that, if they have those two options, what the hell is diffused XML? Like it's not like the API design was not intended to communicate to the developer what is the advantage of using this API versus another API. So the developer, if they have to choose between that two, I don't know, I'm just going to choose xml.parse because that is more of what I'm expecting. Okay, so this is a chart put out by PagerDuty, and this lists all of the security activities that we do in AppSec. So it starts on the left with threat modeling, and then there's some more continuous stuff like SAST, IAST, SCA. Those tools are running. We're doing code review. We're doing, there's tools that are giving us feedback on our infrastructure and containers and runtime stuff, and there's a lot of human review at all of these places. And PagerDuty put some M's where there's manually stuff that's completely manual, meaning like these are start to finish, these activities are manual. However, if you get static analysis results, somebody's got to look through them, and then somebody has to fix the results of that. So that's manual too. So if you change that to your definition of what should have an M on it, there's M's all over this freaking thing. So when I did consulting for companies, I knew what kind of resources they had, how they didn't have that many humans to cover this many M's. And so what we would do is we would rank our applications, from least critical to most critical. The internet-facing ones that touch sensitive assets, those are the ones that got really much human attention at all. And so we're already only covering, let's say, really paying attention to like 10% of our inventory. And by the way, these M's are not just coding. There's product management discipline, project management discipline. There's all kinds of stuff that goes in here. It's not just one skill set. And a lot of the tension in between development and security occurs because we're not really good at the other person's job. We don't know how to empathize, we don't know how to communicate, we don't know how to estimate. And so things sound like they should be easy for them to do. Actually, they're kind of hard. And so lots of M's here from lots of different roles. So I think I mentioned we don't have enough humans. So Other people, there's a lot of reports that say developers outnumber security 100 to 1. I feel like that number's worse the bigger the company. You know, like your AppSec program at a big company, like a giant company, giant enterprise, might have 50 people, and they all have 20,000 developers. So just the numbers don't work out today. People are security is drastically outnumbered. I think I mentioned the humans we have aren't cross-skilled on each other's areas, so developers aren't good at triaging vulnerabilities because they're not super familiar with the vulnerability classes, and security doesn't really know what the fix should be for these things because they're not developers. So again, what ends up happening? We only end up covering a few parts of our portfolio. So what's going to happen here? Like, I'm waiting for somebody to tell me what the solution is going to be. We're about to. I pulled a number out of thin air earlier, and I should have referenced that number. If Copilot is giving us a 25% throughput boost, what are these other GitHub tools? What are these other Copilots that are more junior engineers, agent engineers, going to be giving to us? Is it a 500% boost? Nobody knows, but it feels like a hell of a lot more. It feels like a lot bigger number than 25%. So if I just pick 500% out of thin air, I think that's conservative. But if I tell you all those M's we have in that chart, who's going to be doing the work? Who's going to be doing the code review on those, for what the code the robots write? Who's going to be looking at the static analysis results? Who's going to be reviewing the bug bounty reports that come in? Nobody knows. Nobody has an answer to this question. And so we have to sort of orient around how do we live in this world? Because I guarantee you, if I just said to you one day, Miss Security Person, like, if I'm going to 5x your workload, I'm pretty sure that would be a surprise, and that would be a really disastrous result in some disastrous new trade-offs that you're going to have to make, and the risk that your customers are going to have to absorb. And companies are not going to make the decision of, well, we're just not going to use Copilot because it introduces too much risk. They're going to use them because they have to be competitive. That's just the world we have to be in. They're not going to cut off a major tool for themselves. So it's happening. What can help scale? So one thing that helps is this concept of paved roads. So this is an upfront investment that we make in our architecture, in our APIs, where we make it really easy to, or we make it only possible, actually, to introduce new features that go through a paved road that has security built in. So you might, if you have a web app or something that you want to add a new API to, the only way to add a new API the way your API has been built is to use X, and X always provides authentication. You have to opt out to create an unauthenticated endpoint, and that should send off, red alarms for review. And so, this is like common thing to, like, we all have another control that's built in, and so we want to make it hard to be insecure. And so, let's go to the next one. This is another common one we see. Like, we don't allow anything except, cross-site scripting is a very popular vulnerability. It's very easy to make that mistake and create that vulnerability in your code. But if you use REST APIs and you use a data format like JSON and you kind of do those in the right way, it's hard to be vulnerable to that class of stuff. So paved road there, we follow this pattern, and then something interesting happens. The robots want to make your new code look like your old code. So they do follow the patterns you have. So, yeah, and even today, just with Copilot, if you write a test, if there's 3 tests and you write the first 2, it kind of knows what the third one will look like. It knows the format, it knows the APIs to use. And so it'll copy the patterns you use. And so the paved roads here will also be at the same time treating our robot how to work with us. And this is also true of your pipelines, right? Like if your pipelines, there's the only way to have a pipeline is to also include static analysis in it. Great, right? There's no way to get around that. And the bigger of a company you are, the harder this is because, you know, you're a company enterprise that makes 7 acquisitions a year. You're inheriting, you know, all kinds of technology of every type, pipelines of every type, different kind of security levels. And so this is so much easier said than done. But this will help, you know, this is an investment that we make once and we get paid back for it. The robot, again, will start copying our patterns and yeah, we make it hard to be insecure. So something else that really works is this class of technologies called runtime application security protection. I used to work at one of these at my old job, and I'm super bullish on this space that makes, you know, when I was first coming up in the year 2000, we had a different worm every week. It was the configure worm, the I love you worm, the slammer worm, and the reason they stopped happening wasn't because developers learned how to write secure code. It wasn't because we made new APIs and we trained them and blah, blah, blah. What happened was we added protections to our tool chain, to our compilers. We added in these stack cookie things that made buffer overflows hard to exploit. We added, you know, we randomized the address space layout of our operating systems so that exploits wouldn't know where to jump to when they took over control of the program sort of position pointer. So there's lots of things that we did to the runtime and the tooling and the tool chain so that even if you could get an exploit, it's very hard to turn that into reliable code execution. Like living from my experience, you know, where all you had to do was find one memory corruption sort of primitive to get, you know, to pop a shell. Now today, if you find a vulnerability in Chrome, if you pop Chrome, you know, they give you a fucking award called Pony, and it's like worth $1 million because you need to chain together like 7 different bugs. And you know, you need a sandbox escape, you need some way arbitrary read 4 bytes here, then they're all a work of art and they're all way beyond me. So about our strategy there was not let's teach our way out of this problem. The idea was to build stuff in that made exploitation more difficult. And so this is what runtime application security tools do. They instrument sensors into the runtime. So they'll add sensors to your custom code, to your libraries, to your framework, to your whatever, to all the places, and we can create little firewalls. So if you remember log4shell, that was a vulnerability that, you know, you would be in some, you know, when an exploit occurred, you would be inside a logging statement, and then somehow you would be running a system command after. There is absolutely no reason those APIs should be able to call each other. So, and you can do that kind of thing with these sensors, actuators, whatever. If we can instrument your code to say, you know, the first thing that we do in the deserialization code or the shell popping code is check to see if we're within the scope of a deserialization event or a logging event or something, like, just stop that. Like, we don't have to do that. Those kind of behavioral rules, those higher level rules, are easy to specify, and they're very hard to avoid. So for an attacker to bypass this is quite difficult. And so this is an example too of what we have here. So is a user provides some input that looks a little sketchy. And let's compare this to a web application firewall, which is traditionally the solution for this type of problem. When does boom happen for one of these application layer attacks? It happens within the app, right? If the firewall has to make a decision about this input this early, when it sees the web traffic, it's going to be wrong a lot. And the second that it's wrong and it blocks legitimate traffic, it's getting turned off or it's getting turned on to log-only mode. And so that's why most of our WAFs are in log-only mode. So it's too far away. It doesn't have enough context to decide, is this an attack or not? However, if we have sensors in the SQL driver, we can check to see, does this input, we can do a single pass, static and like a semantic analysis. We can do turn this into an abstract syntax tree and actually see, does the input that we saw come into the system appear in this query, and does the code or does the data that they gave us escape into a code context and change the meaning of the query, change the structure of the AST of the query. And this is something that the upstream security tool cannot do. Right? This can only happen within the application itself, where boom is actually happening. So this type of protection makes it really hard to, it's hard to exploit. So our first strategy was make it hard to be insecure. Second strategy was make it hard to exploit insecure code. And there's probably 10 things we could talk about, but we don't really have time. One of the things we're going to need to do is automate the human interruptions from our security tools. So basically, if we're giving the robots the ability to generate all this code, and all this code is going to be part of our attack perimeter, without the humans there, we're going to need to automate the things that we would do that come out of those, the activities that are done in response to those interruptions from those tools. So for example, if we have a static analysis tool that finds something, there's nothing to say, there's no magic that prevents us from using robots to also look at that vulnerability, look at every step in the chain, and decide, is this, it's a slightly different question to say, what are some attributes of this vulnerability that they're telling me exists? Compare that to, knowledge that was been built up about the repository, and decide if it's true positive or not. And then if it's a true positive, actually, issue the code, issue like a pull request to fix it. And then if it's a false positive, triage it, shut it down in the dashboard of truth or whatever. So we can use robots to also help with this problem as well. So this is where I spend most of my days researching solutions here. And there's a couple tools here to look at. And one of the tools that we work on, an open source tool to help in that particular problem space, is CodeModder. So CodeModder is a framework for building code mods. Code mods were this idea, they came out of Facebook originally for doing mass refactoring of code. It was like a Perl or Python one-liner. You give it some code that looked like A, and it would change it to code that looked like B. And it kind of died within Facebook, and then the JavaScript community brought it back. And they made a library called JS CodeShift, and they use it to automate migrations. So like if you're on React 4, they give you this code modification that changes all your APIs to use the new APIs. And I looked at this and I was really astounded. Why don't we use this to solve more problems? And the reason is, it's very difficult to be expressive about the code you want to change. So there's two sides of this. There's the code you want to find and what you want to change that code into. And so these tools were all taking a very ocean-boiling approach of they were writing all new logic for expressing both of those things. And so we took a different approach, and we just made it easy. We made an orchestration library that connects tools that are great at querying code that like are very expressive about how you find different things. And these are tools that you use every day to find problems in your code. And we stitch those together with the community-loved idiomatic solutions for mutating source code. Things like Java parser or libcst for Python, JS code shift. And we just made it really easy to connect these two things. So if you want to scale with the robots and you have a consistent problem that's occurring out of these tools, you can write a code mod that says every time the tool says X, I want you to fix the code with Y. So here's an example of this. Super simple example. Don't ask me too many questions about it because I'm not a Python guy. Somebody else wrote this. But what you can see here is we've stitched together semgrep, a semgrep rule, with a libcst function. So you can see in those triple quotes, you can see here this is the tool, this is the library. We've written this semgroup rule that finds random calls, and then our library does the magic of connecting that to libcst here, and so we give you a callback when that happens. Every node that matches this will be sent to this function. And so every time we see that, a function that matches that, we'll replace it with secrets.systemRandom, and we'll add the missing import, and Bob's your uncle. So we've invested, I don't know how many thousands of man years in these existing tools. We cannot build them again. That would be an absolute waste of time. So we have to take the results of those tools, make it really easy to work with, with the new code mutation technology we have as well. So here's some of the links for that. Again, you can look for CodeModder, and you'll see a lot of that stuff on the web. So we have to figure out as a community, I believe we're barreling towards a sort of climate change level event with these tools and the amount of code that they're producing. And again, it's probably less secure if we had to summarize the research from all these organizations. And developers are yet, paradoxically, having more confidence in them than the code that they write themselves. And so we cannot increase the quality of the models to get our way out of this for a few reasons we also talked about. So we need to figure out how to make code hard to be insecure, and then when it's insecure, make it hard to exploit, and try to automate the discovery process from a lot of these tools along the way. That's my pitch. Thank you. Any questions? Yeah, the paved road strategy is really like the pattern for, developers. I hope I'm a developer, so I'm not saying anything pejorative here, but like we do the same 5 things over and over again when we make an app. We make a REST endpoint, it takes X and it spits out Y. So the concept of the paved road is there's one way to do that. There's one way to take X and give you back Y. So that's how we structure our API. And then, but the way you take X and the way you give back Y have security built in. Authentication, access control, validation, output encoding, logging, error handling, like all of those cross-cutting security concerns are baked into the API. And this requires a massive investment from the team to build an architecture that forces you to do the right way. Even if you don't understand it, you don't understand the need for it, like we don't care. You need to provide a role here, an access control rule. And so it's really in the libraries we build for ourselves that's where you do that. You can also abstract the concept into other things, like there's a golden, like if you want to have, one container that everybody uses that strips out the useless artifacts that nobody needs. So there's ways in which you can try to scale that in other places. But yeah, traditionally that concept has meant, there's a right way to do things, and the right way and the only way has all those security concerns baked into it. Yeah, I think there's a lot of low-hanging fruit that that it's, like objectively better. Just like we don't have to argue about it. What you may have to argue about is it exploitable? Which I believe the more and more in my career is a giant waste of time, but developers sometimes do make us go through that exercise. But if we don't make any claims about that, if we just say like, we can't chase down if this is exploitable. Like automation has a really difficult time doing that and making that assertion really confidently. But it is no doubt better for you to use parameterized queries instead of unparameterized queries. So for me, it's like we could spend time fighting about it, or you can just click the merge button. And so that's one way to attack it, is to say like, we're not going to argue about it. Like we can just fix it, and everybody will be better off. But I think there's other vulnerability classes certainly that are a lot more difficult to say like, I know exactly what the fix here should be. I think that people will get themselves into trouble and be wrong a lot. But yeah, I think there's enough low-hanging fruit in the sort of like OWASP top 10 kind of stuff that I think we're going to be, that there's a lot of opportunity for no-brainers. Yeah, I think it's going to be a lot of just like my whole life in security. Like I'm going to have to automate the business is going to do what they're going to do, and I'm going to have to automate the verification of it. Like verifying a robot's code, we have to do the same activities. And if we just scope it down to like the static analysis part, we can still scan it and find some classes of vulnerabilities. Scanners don't find everything. They don't find access control and authentication stuff that's specific to your business. So that sucks. So we will still have that gaping hole. But maybe you can make a bot that you tell it what are the rules for your company. Like, hey, don't block any PRs that introduce a new REST API endpoint that don't have a authentication annotation on them. It's very deep in the weeds example there, but I think we have to figure out some gates to let us know when manual intervention is really needed. And I don't think we have the tools yet for that. Yeah, it's a good. Is there a paradox there? I mean, I think none of the people that I might have some bias in the people who I talk to, but the people I talk to at the big enterprises there was a lot of hesitancy since Copilot sort of was first released, but now they're changed their tune. And I don't know whether the business has changed their tune or the security teams have changed their tune, but everybody's going to be doing this. And it's not like if you think about quality as like the little micro patterns of code, like it spits out high quality code sort of in the micro context, but on the macro context, it can't reason, so it doesn't, I don't know, so it looks like good code. It doesn't have all the code smells that like a junior developer would write. they have unused variables or whatever, like the other obvious tells that the code is bad. It won't have those. But yes, it will be subtly bad. And there's an interesting question behind your question, which is why do we do the activities that we do, the security activities that we do? And I'm sure there's a lot of people in security that are very cynical about that. Like, we do what we need to do because compliance tells us to, or this is what's expected by the board or whatever. So I can't answer that question, but I do believe that everybody is going to be doing this, right or wrong. No matter how puritanical they may be about the quality of their code. Yeah, that's good. That's a good question. A lot of those terms are being used interchangeably everywhere by everyone. And typically when I say, so Copilot is a general, people use that as a general term to describe an agent that is helping you perform the task that you already do today, but quicker, better, more efficient, whatever. So that's generally what people mean by Copilot. And I do think we're going to need Copilots that ride alongside the code generation tools that help them secure their code, help them eliminate the interruptions. And so the form that those copilots would take, like if they're in GitHub, they would be called a bot. That would be the form factor that's how GitHub describes the automation available in GitHub. But when I say bot, I really do mean generally just any AI agent. Yeah, Copilot is like sort of taken over the term, and now anytime anybody says Copilot, they sort of think about GitHub's Copilot, but or something that's going to be helping you draft whatever your unit of work is. But we're going to try to take it back, I think. Any more questions? Oh, good question. So rather than having multiple LLM or having the one giant LLM, I mean, do you mean literally in the generation of code part of the process? Because I think sort of what I'm proposing is that it's like we're going to have an LLM that's really good at understanding how to act on SCA results and automate that. It'll probably still be built on the same foundational models that everybody uses because it's not possible for us to all create our own foundational models. But yes, we will be using fine-tuned models for a lot of these actions all over the place. But I don't believe that it will help us write more secure code. I don't think it'll help the Copilot tools like GitHub's Copilot write more secure code. All right, thank you very much.